Welcome back. Last time we left some simple exercise for serious students, or either exercise for serious students. Today, let's have a look at this very exercise and we'll call it a day. Okay, if I'm to differentiate root of x from first principles, remember root of x can be written as x power half. So I'm going to let my y, which is the function f of x, to be root of x. It implies that if I'm to introduce a smaller change in x on the horizontal axis, I introduce a smaller change x plus h, it is going to become x plus h power half. Remember, this is x power half, as we said. So this is a function still, which we can easily find on that very curve, but having a very smaller change, a very small value. Okay, so if I'm to get delta y over delta x with the limit as h tends to 0, I'm going to have change in y. Change in y, it is the y value minus the y value, y2 minus y1. So it is going to be x plus h power half minus x power half divided by x2 minus x1, which is x plus h minus x1, which is x. Okay, forward we move. Then we are going to have delta y over delta x as limit as h tends to 0. This is going to become x plus h power half. We are going to rationalize this number because we cannot easily open this bracket, but once we rationalize, we are going to see something is going to work out. So this x is going to cancel, we remain with h. So if I'm to rationalize the numerator, I'm going to put this very value, but I just change the sign. That is rationalization. So I multiply it, I create a useful one, I call it a useful one. You are going to see why it is a useful one. Power half. Okay, so it is this very number, this very value, but you just change the sign. Clear? So you divide through by that very value plus x power half. You see that this value can still cancel, so we have really changed nothing. So this is a useful one, such that this is a 1, so it's multiplying by a 1 and dividing by a 1. So I can still cancel out this value here and I go back to my original value. Okay, delta y over delta x is going to become, remember, limit as h tends to 0. Now if we are to look at this, x plus h power half minus x power half, this is like having a difference of two squares. If I have a squared minus b squared, it becomes a minus b into a plus b, a minus b into a plus b. So this is like a difference of two squares, so I'm going to use that. So this one is going to be x plus h power half, okay, squared. So and if I square, it becomes x plus h minus b, which is x, okay, squared, which is becoming x, divided by h into x plus h power half plus x power half. So delta y over delta x is going to become, this is the limit as h tends to 0. H is a very small value, x is going to cancel, remain with h over h into, remember this h is multiplying everything in this bracket, so this is x plus h power half plus x power half. Hope that is clear. Okay, so now we are going to have this h cancelling with that h, so delta y over delta x is going to become, with the limit as h tends to 0, 1 divided by x plus h power half plus x power half. Then we state our this that as h tends to 0, delta y, we state our condition over delta x tends to the y, the x. Now, the y, the x as h tends to 0 implies that this value here is tending to 0. If this value is tending to 0, we shall only remain with the x power half. So it is 1 over x power half. H is tending to 0, so we ignore that, plus there's no h here, we remain with the power half. So it implies that dy, the x, is going to be 1 over x power half plus x power half. These are two x power halves, so this is dy, the x is equal to 1 over 2x power half, which is 1 over 2 root of x. So differentiating x power half from first principles is going to give us that. Thank you very much. Next time we are going to look at other ways of differentiation, the simple ways we can differentiate numbers easily. If we are not told to differentiate from first principles, what can we do? Very simple. Just subscribe to my channel and comment for queries. Thank you very much.